So, welcome. We are going to start looking at chapter 3. Now, we really get into a lot of statistics here in chapter 3, where we start talking about a lot of these measures of central tendency. So, the first thing that we're going to look at is some data that we've been given by an investment firm. So, we have Vanguard, who is a large investment firm, and we've got two of their mutual funds, their growth index and their value index. And we're going to be looking at their data and examining it throughout the chapter using various measures. So we're looking at some samples from 2007 to 2016, and here's the data that we have. So if you're wanting to follow along in Excel, in the Chapter 3 Excel worksheet that's posted there in Blackboard under Lessons, you can open up that Excel spreadsheet. We're looking at growth underscore value spreadsheet, and we'll come look at that at the end of the video as well. But that shows all of the data for 2007 to 2016. So the first thing we're going to look at is what we call measures of central tendency or measures of central location. So before we get to this, we need to talk about these are appropriate to use when you have data that follows what we call a normal distribution. That's that traditional bell curve kind of distribution that looks something like this. So as long as we've got something that's roughly similar to that, doesn't have to be exact, but roughly similar to that, then we can use these measures of central tendency. But if we have something that is very skewed one way or to the left or to the right, either positively or negatively, then these aren't the best measures to use. So as long as these are somewhat symmetrical, and I admit that my diagram that I drew here is not very symmetrical, but somewhat symmetrical here, then we can use this. Now, also, as we get started in this, we need to have a discussion about our Greek alphabet and remember our Greek alphabet because we use a lot of Greek letters in statistics and in math, and so they mean certain things. So when we're taking the first of the central measures of central tendency that we tend to look at is what's called a mean or an average. So we all know how to take an average by now. You know that you add up all the numbers and then you divide by how many there are. Now, if we are taking an average of a sample, then we are calculating what is called X bar. And so this line on top is the bar. And so we would say this as X bar is how we would say it. And so the numerator is the sum of all of the variables in the sample. So the Greek, this weird looking backwards E thing, this is the Greek letter sigma, and sigma always means sum. So anytime that we see that, we're going to sum or add up all of the variables. So X is traditionally our variable, whatever it is we're looking at. And this little subscript I is just referring to the placement. So we'll have like X1, X2, X3, X4, X5 if there were 5 items in the sample. So it's saying add up all of the variables in the sample. And then you divide by the number of items in the sample. So that's the lower n. So lowercase n is the sample size. So if we wanted to calculate the population mean, if we could calculate the population mean, that instead of using X bar to represent the population mean, because that's the sample, we're going to use this funky looking M thing here. And this is the Greek letter mu, spelled M-U, pronounced M-E-W, like new and mu. So this is the Greek letter mu. Mu is for, again, your sample population. So your numerator is the same. It's the sum of all of the variables in the population. And then we're going to divide it by the sample, the population size. So notice that we use the capital letter N to indicate population size. So typically, and this is just kind of a good rule of thumb, samples, if we're talking about the sample, we're going to use a lowercase letter to represent that. If we're talking about the population, we use the uppercase letter. So mu and is the population mean, and it's the sum of all the variables in the population divided by the population size. So looking at the data for the growth fund, we would just add up all of the different returns, divide by 10, and that gives us our average return. And we do the same thing for the mutual fund. Now, these are samples, not the entire population. So these are the X bars. So we can see that on average, over from 2007 to 2016, the growth mutual fund had an average or mean return of 10.09%, and the value fund had an average or mean return of 7.56%. We're going to come back at the end of this video and look at how to calculate all of this in Excel. Now, while the mean is the most commonly used measure of central tendency, it can be influenced by outliers. An outlier is any number that is extreme to one end or the other. So we have to be careful of outliers as we're looking at our data, and we'll talk about this more as we go throughout the semester, but outliers can dramatically skew our data. So if we notice that there's an outlier, and we're going to get in a little bit to a video of kind of a way to check is what is an outlier, we need to ask ourselves, we need to research and see, is this an outlier because it is a mistake, perhaps something was recorded incorrectly, or is an outlier just because of random variation? So as an example, if you are looking at temperature, if you're working with maybe some hospital data and you're looking at average temperature or temperatures of patients, maybe after surgery, post-surgery. Okay, so we're documenting the temperatures of the patients when they come out of surgery, and maybe 1 hour after and 2 hour after, or whatever, we're taking their body temperature. If you see an outlier that's like, let's say 120, well, we know that that has to be a mistake. Nobody can have a body temperature of 120. Chances are that was just recorded wrong. Maybe it was supposed to be 102 and they accidentally transposed some numbers there. Maybe they just hit a wrong number, but clearly that's an outlier. So we would want to remove that one because that's clearly an outlier. That's not even in the realm of possibility. You cannot even possibly have a body temperature of 120. So we would want to just remove that, like, oh, that's a bad piece of data, right? But if we're looking at, let's say, the class average on a particular test, well, maybe we had a student who didn't show up to take the test, so they have a 0. Well, that's going to pull the class average down. So that's an outlier. So we may want to leave it in there to say, well, you know, the average on this test was, I don't know, I'm making up numbers here, 65. But if we take out this person who didn't show up to take the test, then maybe the average is a 75, right? So we may want to look at it both ways, with the outlier, without the outlier, in that sort of situation. So it just depends on what your data is, and you're really going to have to use some professional judgment. Do we need to leave the outlier in because it really is a possibility, or do we need to take it out because it's obvious that it was a mistake of some sort? So if we look at, here we're given salaries of people that work at this particular company called Ace Tech. So since we're only looking at this particular company, we're calculating the population mean at this point because we have all of their salaries, right? So we are calculating the mu, so we can add up all their salaries, divide by the number of people that work there, and we're told the average salary is just over $154,000. Now, that may be great, except if we look at this, we're going, well, the average person doesn't make $154,000. Clearly, the president, who makes over $500,000, is the outlier here and is skewing the data heavily that way. In fact, notice that the average is above every other person except the president, right? So in this case, the average, the mean, is not the best measure of central tendency. It doesn't really give us any good information. The average person who works there does not make $154,000. So we could either exclude the president and calculate the average maybe of all the normal people working there, or we might want to look at some other measures of central tendency. So we could look at the median. The median is the middle number. So you would rank the numbers in order from smallest to largest, and then you're just going to pick the middle one. So if there's an odd number of observations, then it's just the middle one. If there's an even number of observations, then you take the two in the middle and you average them. So now if we look, there's 7 observations here. 7 people work for this ACE Tech. So we can look at the middle person right here who makes $90,000. So the median income is $90,000. This is always really an important one to look at, especially when you're looking at data that has salaries and things in it, because there are so many outliers like that. So a lot of times when people are looking at data about a particular city, one of the things that's commonly reported is the average income of that city. Well, that can be really skewed. I mean, maybe you have a CEO that lives in that city that makes $1 bazillion, right? And that's skewed the average, because the normal person, the average person, doesn't actually make that much. So it's important in those cases to also look at the median. If you're noticing a big difference between the median and the mean, then you know that there's some outliers there. If there's not a big difference between the median and the mean, then that means there's probably not any outliers that are pulling things down. So maybe it's a better thing is to look at the median income of a city, because you may have one super rich person, but then the rest of the people are just kind of normal. Now, if we look at the growth fund here, we can see that there are 10 observations. So we're going to choose the middle 2 and average them. So we would do that with, for example, observations 5 and 6. So we've got 4 on the left, 4 on the right here. And then we would just average these 2 observations here, observations 5 and 6. So when we average those, we would get the median of 13.02%. So the returns ranged from a -38 to a +36, but the median was 13.2%. So the mode is another measure of central tendency. This is looking at which value occurs the most. Okay, so mode means the most. Now, it is possible for a group of data, for a sample or a population set, to have no mode. If there is no particular variable or observation that occurs more than once, then there's no mode. You could also have multiple modes, right? So if you have 2 observations that both occur 5 times, then you may have 2 modes here. So this one is, again, it depends on the kind of data that you have, but we may be looking at, for example, maybe we're looking at data about side effects after our side effects from a particular prescription drug. We may want to look at the mode, which is the one that occurs the most, right? That sort of thing. So here, if we look at the data of the employees at ACE Tech, we can see that there are 2 employees that make $40,000 a year. And those are the only 2 observations that are the same, or the only observations that are repeated. So the mode here would be 40,000. Now, we also calculate a weighted mean, and you are used to calculating a weighted mean. Almost all of your averages in your classes are calculated using a weighted mean. So instead of just summing all of the observations in the numerator, you would weight them appropriately. So for example, maybe tests are weighted more than homework, and quizzes are maybe weighted more than homework. So you'll take each observation and you will multiply it by its weight. So if the tests are weighted maybe 20% apiece, then you'll multiply each test grade by 20%. And then maybe homeworks are weighted 10%, you'll multiply each homework by 10% or whatever it is. And then you add up all of those in the numerator and divide by the sample or population size. So here we're told. So now to calculate a weighted mean, here we're looking at exam scores. So let's say that the student scored a 60 on exam 1, a 70 on exam 2, and an 80 on exam 3. Now I want to point out, if we were just going to calculate the average, if we were going to calculate x bar, or really I guess this would be mu, we would add up 60 plus 70 plus 80 and divide by 3, which would give us an average of 70. But here we're told that these averages are weighted. So exam 2 is worth 25%, exam 3 is worth, exam 1 is worth 25%, exam 2 is worth 25%, and exam 3 is worth 50%. So now we want to weight these. So we can say W1, or the weight of observation 1, is 0.25. We converted the percent to the decimal. And W2 of the weight of observation 2 is also 0.25. And W3 of the weight of observation 3 is 0.5. So now, to calculate the weighted mean, notice our formula is the sum of the weights multiplied by the observations. So we're going to multiply 0.25 times 60 plus 0.25 times 70 plus 0.5 times 80. Notice we don't have to actually divide anything here. So now, because this is weighted and the student did the best on the test that has the highest weight, the student's weighted average is a 72.5 as opposed to their straight average of 70. So they did better because they did better on the test that's weighted the most. Now, before we switch over to Excel, I'm just going to make one point and then we'll flip over there. So in Excel, there's a couple of different ways that you can look at these formulas. So we can just go to the formulas menu and go to statistical and look at, they have mean, they call it average, median, mode, all of those kinds of things. Or we can look at the data analysis tool pack. Now you should have already installed or added in rather the data analysis tool pack. That was an add-in that we made in chapter 2. So if you didn't do that, you'll want to go to File, Options, Add-ins, and add in that data analysis tool pack. So if you don't see it appearing in your window, you'll need to add it in. But we're going to look at both of those. And then this is just a list of the formulas that you could use in Excel if you were going to type them in. But I'm going to show you how to find them there.